All right, what's up, CCP crew? We're going to get into some Riemann sums and definite integrals today. I'm going to walk you through the book because I honestly think this is the best way that I can help support you with the resources that you have. So let's keep in mind, all we're trying to do today is describe a Riemann sum. We're going to do a little bit of evaluating integrals, but it's just going to be using geometric properties. And then we're going to learn about definite integrals and their properties, and we'll use the properties to solve integrals, but we won't be really doing any integration in this section, okay? So, I would watch this video if I were you. It's about 4 minutes, and it shows you how to set up a Riemann sum. The Riemann sums are adding up all the little rectangles to find the area, okay? And then they finish that video here, they finish the algebra. And then they go in here just to explain a lot about Riemann sums. So this is saying you don't need every interval to be the same width. I don't think that's super important, but I guess you could know that. This is just saying that if you found the area under the curve to be 2/3, that's what they found, and then you recognize that this entire region is a 1x1 square with an area of 1. So look here, the area under the curve is 2/3. Then what this is just telling you is that you can use your geometric properties to find other aspects of a graph, an area. So like if we wanted to find the area above the curve and under this line, you could simply use subtraction and the area would be 1/3. Okay, so that's what this is telling you, not a big deal. This is the actual formal definition of a Riemann sum. I don't think this will be significantly tested upon item. The thing I need you to know how to do is maybe just by brute force estimating the area under a curve using rectangles, okay? That's all the Riemann sum is doing for you. Okay, so now this video is also about 4 minutes, and it now starts to show you the difference between using an approximation, Riemann sums, and then using a limit approach, which will actually find you the actual area under the curve, okay? This is essentially the transition from limits to an integral approach, which is the fundamental theorem of calculus. We're almost there. That's the next section. Okay? Here he'll show you the fundamental theorem of calculus. So actually, this is a little teaser into section 4.4. So I would watch this video as well. One thing you're going to pick up from this video is we're going to call the integral of a function the parent function, the function that if we took the derivative of it, it would give us this lowercase f. We're going to call that uppercase f. So that's something I would want you to pay attention to there. Again, they're actually doing the calculus here. We will not be doing that in today's lesson, but I do think this is a good thing for you to watch and look ahead. Okay. Now the rest of this is just helpful integration tactics that helpful tactics to find the area under a curve that don't involve integration. So first, before we get there, this is saying that any function that's continuous under a closed interval will be integrable. We can find the area of it. It does exist. It might be super hard to do this. A comment that I'll make to you is the integration is the inverse of taking the derivative. And if you think about inverses, they're almost always more complicated. So like squaring is pretty simple. Square roots, that's hard. An exponential function, not that complicated. Logarithms, the inverse of exponents, pretty dang complicated. So integration is more nuanced than derivatives, okay? All right, almost done with the video. Now they're going to show you some key properties of definite integrals. And look, hey, you might want to pause the video and write these in your notes. I don't know what system you're using, but the integral from a to a of any function is 0. There's no width there, so that's the first property. If you have an integral from b to a, that's going to give you the opposite value of the integral from a to b. Okay, that's going to be useful at some points. And then here's the rest of the properties. This is having you practice this. So look, this is 0. And then the integral from 3 to 0 can be switched to the integral from 0 to 3, and we take a negative of it. Now, they just kind of give you the answer. You don't exactly know how to do this yet, but I bet most of you could figure it out. Now we're going to go into definite integrals that can be solved just using geometry. So there's some more properties. Look, if you want to do the integral from a to b, but something's tricky, you can do the integral from a to c and add that to the integral from c to b, assuming that c is in between a and b. So look at this example here. We're going to do an absolute value from -1 to 1. There's a cusp here, so we have a little point here where it's actually maybe, well, that would be a critical point. But anyway, what they're doing is suggesting, instead of doing it like this, just split it up from -1 to 0. This is the function. And from 0 to 1, that's the function. So they're actually teaching you how to deal with the integration of absolute value functions. Just split them up into two linear functions and take the integral. And sure enough, the area under here is 1. Okay? Some other properties. If you have a constant times a function, you can factor that constant out. In fact, you should. Okay? If you have the integral of two functions that are being added or subtracted, you can simply add or subtract the integral. So if you have a polynomial, just take the integral of each part. So notice they're going to do that right here. The integral from 1 to 3 of this trinomial can just be considered the integral of 1 to 3 of the first term, the integral of 1 to 3 of the second term, and the integral from 1 to 3 of the third term. So basically, this is the type of question you'll be answering, one of the types of questions you'll be answering in your homework, where they give you what each value is, and then they just want you to evaluate it. This is pretty simple. Look, you're just adding these by filling in this property right here, okay? Notice that in this one, they gave you the integral of x is 4. Well, this is 4x, so they factored the 4 out. This is where the 4 times 4 came from. Same with the 3 here, okay? So that should be enough to get you started. Here's your exercises, and I'm going to be filling in the rest of the videos this way, helping you read your book, and then supporting you by providing videos on any of the homework questions that you need help with. All right, good Friday. Boom!